So thank you. So we've got Jeff here, W4DD from Gainesville, Georgia, who took my invitation and is staying up a little late for us. And I think his topic on radio frequency interference probably in some way has affected us in some way, all of us at one time or another. So I think he's got some great information on how to find this and maybe how to curtail it. And so I'm going to throw it over to you, Jeff. Thank you very much for being here today.
Oh, thank you, Rob. Let me bring up my presentation. And you should see a map.
Hey, it's working.
Good. And let me do one more thing here, share sound. Okay. And let's enlarge. There we go. So I'll be talking about RFI and mostly on the receive side this evening. I got interested in RFI about 15 years ago when it was quite significant when I moved to Georgia. I live in a relatively rural area, but that doesn't mean there's not plenty of noise to combat. And with all the appliances appearing in the marketplace, RFI is going to get worse. We're going to need to be able to solve this on an individual basis. So we'll talk a little bit about what is RFI, whether or not you have it, some tools. So first, some simple tools to locate RFI, and then some much better tools. We'll give some examples, talk about clearing distance guidelines, how far out from your QTH should you have to look, and then some results I've had over the last 10 or 15 years. So RFI, for newcomers, it's an acronym, radio frequency interference. It's a term used to describe something that's not desirable. You don't want RFI, you'd like a nice low noise floor. What RFI does is it raises the noise floor, and the higher the noise floor, the fewer signals we can hear. So it's basically background noise when you're trying to hear a desired signal, either DX or continental or local. When the noise floor is low, you can hear really weak signals. So you always want to strive for the best, lowest noise floor. Lots of different devices make it in today's world. Two most common things I run across: power lines and switching mode power supplies. It's really not unusual to have multiple things within a house creating noise. One's normally dominant, but you find you clear the dominant noise source, and there's another one or two or three hiding below that dominant noise source. First thing, and probably the most common for us in the Southeast, is power line noise. It's basically a spark gap transmitter, just like they had 100 years ago. The effectiveness of that spark gap transmitter is really dependent on two things: the intensity of the arc, how much power it's producing, and the antenna or the power lines connected to it. And it can go from very minimal to, I've seen 20, 30 dB over S9 that really blocks out everything. Lots of causes. I find the most common things: defective insulators, either bells or pole tops, defective lightning arresters, or metal to metal arcing on the pole. One characteristic of PLN, it's usually wide band. It extends all the way from 160 meters up through VHF and even UHF. And that's something a little different than switching mode power supply, which tends to be more focused on the lower bands. Second kind of noise source I see quite a bit is SMPS noise. And there's all kinds of devices. The old linear power supplies that used to power everything 20, 30 years ago have now been replaced by the very low cost switching mode power supplies. Those SMPSs don't work at the traditional 60 hertz. They have their own oscillator internal in them, and as such, if not well designed, they'll generate all kinds of hash, especially up to about 20 meters, but sometimes even higher than that. They typically run at a frequency of 15 to 50 kilohertz versus a 60 hertz power line. And if they're not well designed, they can create a lot of hash. And one of the worst is battery chargers. It seems like every time I investigate something, the noise brings me to a garage, and I point to a bay in the garage and say, "What's in that bay?" And the answer is nothing. That's plugged in, and sure enough, there's a battery charger for a lawn implement in that rack or on that desk. So why do we care about the noise floor? Here's two examples taken about a minute apart. The top one is on 40 meters. I had an S7 noise floor. I counted 11 workable stations, and you can see some unusual spikes reoccurring every so often, but even beyond that, the noise floor is quite high. About a minute later, the noise went away. The noise floor across the band dropped to an S5. I could now count 17 workable stations, so I could hear 50% more stations. That's pretty important. I mean, that's not always the case. Sometimes it's less, sometimes it's more. But if you're covering up 50% of the stations with a high noise floor, it's something you want to address. So do you have RFI? You power up your HF radio, you pick your band and antenna of choice, find a nice quiet frequency with nobody on it, set the mode to AM and the filter to 6 kilohertz. And what you should hear is a nice gentle white noise, a nice hiss. You should not hear anything that does not sound natural, including a raw buzzing noise or some other kind of repetitive signal. So if you do hear something other than that nice gentle hiss, you have some investigation to do. So here's an example of what power line noise sounds like. As you listen to that, you can hear some variation, which is one of the characteristics of power line noise. Some types of noise are very consistent. They don't have that little bit of gap in there every so often, but that's one of the things you'll notice on power line noise. It's not always the case, but if you do hear that, there's a good chance it's a power line issue. And you can see in this picture here, it's about 15 dB over S9, so it was pretty strong. So one of the questions I always ask when people ask me about noise, what bands are affected? So I say, fill out this table, 80 through 10 meters. What does the noise look like in as far as S meter reading? And also, what antenna are you using? That kind of gives us an idea. Is this noise rolling off on the higher frequencies, or is it just as strong on 10 meters as it is on 80 meters? So it's kind of characterizing the noise. That's one of the things I use to try and get an idea of what the potential sources might be. You try and learn as much as you can about the noise characteristics. And the other thing I ask, if they have a directional antenna, makes things much easier. And I usually ask the ham to go down through 12 different azimuths, 30 degrees apart, take an S meter reading. And many times this will indicate where the noise is pretty accurately. It kind of depends on how many elements you have on your directional antenna. And it also many times tells us there's more than one noise source. You might hear something at 60 degrees, and then you see another peak at 210 degrees. And many times, usually when I get involved, it's not a simple case of the noises across the street. There's a lot of stuff going on, and I've seen 2, 3, 4, even 5 different noise sources, kind of confusing the issue. So some simple tools I use or suggest people use. One is the circuit breaker test, where you can turn the circuit breakers off to your house circuits. If you can run your HF transceiver off a battery, that's great. Then you can turn all of them off. Sometimes you have to leave one of them on, but you'd like to have only one thing, and that's the radio being powered off that circuit breaker. That works pretty well if the noise is inside your house or inside your neighbor's house. I've used it in both those cases, and it's pretty effective. And if you get lucky, it's inside your house, you can usually control that pretty well. The second very common thing, portable AM radio. You can walk around the house or the neighborhood and you listen for the noise. It's a little hard to tell sometimes if it's getting louder or not, because the sound of noise is not always indicative of how strong it is. But you can get a general idea if you get in the right area. And then the third thing, use your AM car radio. You can drive around, you can listen to the noise. And in my particular vehicle, I know when the AM radio blanks, in other words, I lose all audio, that's a pretty strong noise source. And one of the things to keep in mind is the noise source could be something small, very close to your antenna, or it could be something big far away. And you don't know which one of those two it's going to be. Much better tools. Here are the ones I use almost every noise source I have to investigate. The most commonly used tool for me is the 137 megahertz Yagi, an HT, and an attenuator. It really is good for blocks or maybe up to a quarter mile. If you're only going to have one tool, that's really the tool to have. It gives you a lot of mileage. It provides really good magnitude and direction. The attenuator is really useful for characterizing the strength of the noise source. You know, if it's only a 3 or 6 dB noise source, that's all it takes to quiet that noise source. That's not too bad. If it's, you know, blocks away, it's probably not going to bother you too much. But if it's a 45 or 50 dB noise source, that's a big noise source. You're going to hear that, you know, for quite some distance, half mile, 3/4 of a mile or so. Second most useful tool for, at least for power line noise, is an ultrasonic dish. You can ID the part on the pole. That's an audio device versus an RF, but it's very handy sometimes. And I'd say probably about 90% of the time it can zero you in on what part on the power pole is causing the problem. And the third thing I use quite commonly is RFI Mapper. It's a program I wrote about 10 years ago. It allows me to collect data by driving around the suspect areas and produce a map, and gives me pretty good, clear indication of where the noise is being produced. And it'll tell you there are a lot of noise sources. It's your job to kind of figure out which ones are important and which ones are not. And that provides both location via GPS and also a magnitude indicator. And also elevation comes in handy sometimes too. The GPS gives you elevation. So it works pretty well for those things. And we'll talk about all three of those. I didn't mention it when I started, but if you have any short questions, feel free to stop me. If it's something that's going to be a little longer, if you'd hold it till the end, that'd be a little better probably. So the first thing I use is the VHF Yagi. I have an old Yaesu VX5R, and it works in AM mode. And I usually listen in the 137 megahertz aircraft band, or around 136, 950 or so. It really is an essential tool. I use it, you know, all the time. It's good for even power supply noise, switching mode power supply noise. In my case, I built this prototype a long time ago, maybe 15 or 20 years ago, and I had an intention to rebuild it to make it look better, but it works so good, I just have left it the same. It's built on a broomstick, reclaimed broomstick handle, and it uses some 10 gauge wire for the elements, and a piece of coax and a PL259. That's all there is to it. And it has good 20 or 25 dB front to back. And that's what you want for noise hunting. I also have an old reclaimed attenuator I rebuilt out of a cable TV attenuator that was no longer working. I redid the resistors and the switches, and it provides me 4 different levels of attenuation, 3, 6, 12, and 24, for a total of 45 dB of attenuation. And I use that all the time also. Very useful. So I always get asked why I use 137 megahertz. A couple of reasons. AM works best for finding noise. You can hear the characteristics of the noise much clearer, and it's much better defined. And some HTs only do AM in the aircraft band, and I used to have an HT like that. It would not do AM at 2 meters, only in the aircraft band. Second reason, HTs will not transmit in the aircraft band. So if you accidentally depress the PTT button, you're not going to smoke the attenuator, which you built or bought. So it wouldn't be good if you were out working with the power company doing some investigation, and you hit the PTT button and you burn up your attenuator in the process, and the smoke came out of the attenuator. That would not set the mood very well with your power company. You want to look like you know what you're doing. And I worried me a little bit that sooner or later it's going to happen. So I said, hey, you know, if I stay in 137 aircraft band, I'm safe. I find VHF provides really good range and pole resolution. I can hear larger noise sources out to quarter mile, even third of a mile in VHF, but I can also work in close to the poles where they're only, 50 or 100 feet apart. And usually there's a quiet frequency at the very top of the aircraft band. So a few hints for using the HT, the Yagi attenuator. I'd say it's a must-have if you're going to work with a power company. It confirms what pole they should be working on. You can have the audio turned up so they can hear what's going on. You can point back and forth between two poles, and it should be obvious as to which one's causing the noise. Noise loudness is not always indicative of the RF level. You want to go by the RF level. Sometimes noises sound really nasty, and then you actually flip in the attenuation and you go, this is only a 5 dB noise. It's just not significant unless it's right on top of your antenna. So you really want to go by the RF level, and that's what the attenuator is used for. And those attenuators are really simple. Mine's 4 slide switches and 12 resistors built inside of a box. That's all it is. Very, very simple. And one of the things I do is I rate the noise when I'm working on a problem. If it takes 0 to 12 dB to attenuate the noise to the point where I can't hear it any longer, that's really pretty small. 13 to 24 I classify as a medium. 25 to 40 is a pretty big noise source. If it's more than 40 dB, that's really a huge noise source. And if it's anywhere near your antennas, you're going to hear that guy. Most of the time, those really big noise sources are lightning arresters, but that's not always the case. One of the things I've learned over the years is poles with lots of high voltage lines on them may seem to cause the noise, but you have to be kind of careful. It might be an adjacent pole with just one high voltage wire on it, and that may be the real culprit. But since wire is really an antenna, you need to be careful when you're dealing with 2 very different poles. And one thing I do, and I've had to relearn this, and I think I've gotten it down now after doing it for a long time, always stand midway between the 2 poles you want to compare when you do an A/B comparison between the 2. So you take your Yagi antenna, you point one direction, you flip it, point the other direction, you flip in enough attenuation where one noise source goes away when you're pointing in one direction, and you flip back the other way, it's still blaringly loud. It makes a very binary kind of decision, but you need to be equal distance between the two poles to evaluate them properly. And that's because of a path loss between the two. The distance is what determines the RF attenuation. The other tool I use quite a bit is an ultrasonic detector. Here's a picture of one I built up using, I think it's an Edmunds Optics disc. And I made a few modifications. In my case, I added a 1x scope, which really works well. It allows me to pinpoint usually within a few inches of what the noise source is in the pole. These things are working at audio levels. You have to kind of keep that in mind. So if you're on the wrong side of the pole from where the noise source is, the pole will block the audio. You won't hear it. So you need to go around the pole. I usually take about 8 readings around the pole to make sure that I'm really looking at the right thing. Usually when you're working with a power company, they're going to have an ultrasonic dish, a commercial one, and then you'll handle as the ham, the RF expert, you'll handle the RF locating and get them to the pole. They'll use the dish to find the problem on the pole. But I find sometimes my power line guy isn't available, so I'd like to be able to ID the part on the pole and give them a detailed description of what I think the problem is. So what does power pole hardware look like? Here's a picture of a simple pole. It's a single phase pole. There's only one high voltage line on this pole at the very top. In this case, it was a 14 kV line. Typically, they run 7 and 14 are the 2 common voltages. The very top of the pole, you'll usually see a pole top insulator. And below that, you'll see a tap that goes to a lightning arrestor, and then basically a switch or a fuse that they can disengage the circuit. That feeds a bell insulator that actually feeds the line that goes usually close to the house. And then below all this, you'll see the neutral wire and sometimes some cable TV and telco wires. but these are kind of the components of the pole. I have a pole top insulator here. I'll show you what they look like. And this is some heavy duty hardware. This thing weighs about 7 pounds. It's really well built and sits at the top of the pole. There's a slot at the top. The wire goes through the slot, and they take another wire, a thinner wire, and they wrap it around this little groove at the top of the pole top insulator, and that holds the high voltage line down in the slot. This pole top is supported by a pin. Here's an example of what the pin looks like. The pin screws in the bottom, and that's what keeps it on the pole. And then there's 2 holes, if you can see both those holes, that hold this pin on the pole. And another source of potential noise is the bolts that go through this pin over a period of time, like years, 20, 30 years. The pole shrinks, the pin gets loose on the poles, and they'll be arcing between the pin and the bolts, especially if there's a little tension either way on this pin. So there's all kinds of things that can go wrong. That's only a couple. Another interesting thing I found, here's a picture of a lightning arrestor. You can see that there are some fins on this lightning arrestor. High voltage sits at the top, the ground sits at the bottom, and this thing will fire when the voltage goes above about 9,000 volts for the 7 kV lines and about 16,000 volts for the 14 kV lines. The older lightning arrestors were porcelain. They were very, very easy to locate with an ultrasonic dish. The new lightning arrestors it's a rubber material on the outside. They still have MOVs inside, but this very flexible rubber. And I've had a number of cases where the ultrasonic dish could not find the source of the noise. And eventually we did some trial and error, and it turned out to be the lightning arrestors, and it was the newer type with the rubber coating on them. The only luck I've had for these rubber coated ones, if it's a really big arc internal in here, you'll hear it. And the other thing I've done is I point at the bottom bolt from the ground, and it seems like the bolt vibrates enough where you can hear it with the ultrasonic detector. So a few things I've learned after chasing lightning arrestor problems for a while. Okay. So who do you contact once you find the problem? You have to open up a trouble ticket. Sometimes that's easy, sometimes it's not so easy. Kind of depends who you get at the call center. But you want to open up a trouble ticket, and you want to ask that it gets routed to the either the line crew or the engineering department, one of the two. I try and keep the number of issues I report at one time down to a reasonable level. You can go out and find all kinds of noise sources, but you really want them to fix the ones that are causing you problem. So you don't want to give them one 2 miles away. That's probably not your issue. You want to give them the one that's half a block away or a block away. So when I do the survey thing, I try and find the 3 biggest offenders clustered in an area. I'll give them those 3 things to work on. And like I said before, it never seems like it's simple, like there's one problem, it's across the street from the Ham's house. It's more like there's a lot of things going on. It's an older neighborhood. There's 6 different poles making really bad noise, and it's more of that kind of scenario. As the RF expert, your job is to locate the poles that are causing the issue. Not every noisy pole needs to be fixed in the city, only the ones near your QTH. Usually the power company engineer or the line crew will come out and visit the area and kind of do a survey and kind of find out what's going on. They're usually pretty good about that. If you get the right people, that's usually the key. And that's where the HT attenuator and the Yagi come in handy, because if you can be on site while they're doing that, you can show them what you're seeing. You flip the Yagi back and forth, it'll be blasting away in one direction. It'll be totally quiet in the other direction when you flip in the attenuation. Once you go through this a few times, you build up a lot of credibility with the power company. And the next time you report a problem, it's a whole lot easier. So you want to make sure you represent ham radio well. You know what you're doing. You know the RF stuff. They don't. They know the power line stuff, and we don't. So each group has their area of expertise, and you want to kind of combine those two. The third tool I use quite frequently is something I call RFI Mapper. Here's an example of a map I did. This has been a couple years ago now. You can see there's a lot of green on this map, but there's also some hot spots, which I've highlighted with the mapping tool. There were a total of 3 hot spots here. We'll kind of dig down in those a little more here in the next slide. So why did I need a new tool? I had about 10 years of chasing PLN, power line noise, and it was getting really aggravating. I can recall walking the neighborhood when the temperature was 20 degrees and the wind was 20 miles an hour and it was cold. But if that's when the noise occurs, that's kind of when you need to go out and do it. The beam provided a general direction. I had a 3-element Yagi at the time. It gave me a general direction, but that wasn't good enough. They'd come out and fix a problem. The issue might go away for a week or 2 weeks, and then it seems like something else would come back. And after a few years of work, I could just never get the noise under control. The final straw for me was 2 noise sources. One was a S9 plus 10 to the southeast, which was really killing me southeast towards South America and the Caribbean. And the other was a S6 noise to the west. I couldn't locate either one of those. So about 2015, I was a little frustrated. I said, I need a different approach. I'm getting nowhere. And my power company was very cooperative, but we as RF guys need to be able to find the source of the noise. So about Christmas break 2015, I bought a GPS and wrote some beta code. So the result was something I call RFI Mapper, and it produces a color-coded map, and it shows the location and strength of the noise. I can usually identify down to a pole, and the laptop, as I drive around, records the level and announces the levels every 10 seconds. So it gives me a kind of an indication of, am I in a noisy area or not? And if I get into a really noisy area, things above S9, it'll start chirping away at every single second. It'll say S10, 10, 10, and on, or 11 or 12 or whatever. So, oops, let me back up. So the scale I use, I needed to extend the S meter scale above S9 for consistency. So I've defined S10 as S9 plus 6 dB, S11 is S9 plus 12 dB, and so on. So everything is done in S units to be consistent as for the measurement scheme. The low levels where there's not much noise are in green. Then I transitioned to a yellow, orange, red. I ran out of colors, so I also included a white and a black, or the higher levels of noise. And I've kind of found over the years, anything above an S9, you need to look at that pretty close, and anything above an S11 is definitely a red flag, especially if it's within a half mile of your QTH. So here was the first example I produced. This was way back in 2015. My QTH is up here in the upper left-hand corner. It was 1.7 miles away from the final issue. My power line guy and I had spent days up in the upper left-hand corner, and you can see some orange and yellow here, the noise sources. And we actually worked on one of those poles, and they changed some parts on it, and it got better. But it never solved the problem. And so finally I said, I've had enough of this. I tend to get a little persistent, or maybe stubborn's a better word, but I said, I'm going to make this mapper thing, and I'm going to drive every road I can drive until I run into Lake Lanier, which is my southern boundary. So this is only part of the stuff I've driven, but you can see I drove to the east, came down this little section of a road and got near the end of it. And you see some things, there's some blue stars in there and some red. The noise was just horrendous. It was like, I think S13 or S14. And my wife was with me at the time. She was manning the laptop. She goes, "This is the problem, isn't it?" I says, "Yes, it is the problem." So it was really obvious when we got there. And kind of interesting also, there were some noise sources on another ridge line behind the road we drove, but those never have bothered me because they're behind top of a ridge, in dirt, such a good attenuator, they've never been an issue. So knowing the elevation and also the direction and the intensity, all those factors are pretty clearly pointed out where I needed to be looking. And at this time I didn't have an ultrasonic detector, but my power line guy did. He went out and he didn't have any problem finding it. So what was the final cause of this? It was this bolt. And the lineman said when he got near the top of the pole, he could smell something burning. And so it was I guess the creosote or the preservative in the wood was making a rather strong smell. And it brought him right to the problem. And this bolt was arcing to another piece of metal on the pole, a plate. So they fixed this. They re-drilled the cross arm where this bolt went through, and my noise level improved tremendously. It went from over S9 to S3. So for this case, the RFI mapper worked really well. It got me to the problem quickly. I would have never thought a noise source 1.7 miles away from me is going to be a problem, but this thing was so strong, it was a big problem. Second example we'll talk about, I had an area that my power guy said, he asked me to drive. There was a ham in the area and it was having problems locating the source of the noise. So I drove in. You can see there's 3 hot spots on this drive route. We're going to look at one of them. So when I drove into the neighborhood, you can see there was a blue star, which was the peak. I drove out on the same road, so I got a different direction, dots in a different direction, different side of the road. There was another blue star. Between those 2 blue stars was a pole, and that pole was the source of the problem. And it turned out it was a pole top insulator. So that was really an easy one because the RFI mapper brought me right to the pole. The third example, and the last one we'll talk about, is an area that was to my southwest. I think it was 1.3 miles away. It was really bad, and it got worse during the wet weather, which is kind of unusual. But things would dry up and it'd go away. We'd get a little bit of rain or moisture, and it'd come back. So I drove the route. You can see the area, the problem polluted. This is really quite a large area, including the side road, which I think was around 1/4 or 1/3 of a mile. And the peak was right in front of this middle school. So after I produced the map, I said, yep, that the problem is in this area to my southwest, must be it. Went out there and worked with the Yagi antenna and the ultrasonic dish, and found it was a bad lightning arrestor on the pole that supported the power that provided the power for the school. There were three lightning arresters on it for the 3 phases. One of the arresters was bad. While I was working this problem, a police officer came out. I was working it during the normal day. I think it was a Tuesday or so in the morning. And a police officer came out. He was the resource officer for the school, asked me what I was doing. He had a report from some parents. Somebody was out in front of the school doing weird stuff. So I thought, well, I'm in trouble now. He's going to give me a hard time. And I explained I was a ham. I lived in the next neighborhood over, and I was having problems with interference. And he looked at me and he thought a second. I thought, oh boy, he's lost. He said, is this why my handy talkie doesn't work when I'm directing traffic in front of the school?
There you go.
And I said, yes, sir, that's exactly why it doesn't work. This is really a strong noise source. It's totally blanking my receiver. I says, the power company will come out. They'll fix it within a few days. I says, your handy talkie should start to work again when you're out here doing the traffic direction. He did that at the very start of the school day and at the end of the school day. And there'd be a big line of cars trying to come and go. But he was having the same problem as I was. So that was really interesting. He was really nice. And every police officer I've talked to has been really good about understanding what's going on. And they actually are quite familiar with the basics of RF. Another case, I was talking to an officer and asked me what I was doing. I explained, and he says, oh yeah, we use this to track ankle bracelets. I said, yeah, that's right. So they're really pretty familiar with the RF side of things. This is the 4th example. I'm not going to go into this one. Another case of the mapper brought me to where I needed to be looking, and we spent a couple of days working the issues. There were multiple problems on this pole, but we eventually got them sorted out, and and corrected. So how does RFI Mapper work? Really pretty simple. Every 1 second, the GPS will send lat long to the laptop. That'll trigger the software to read the S meter. So it queries the, I have an old Kenwood TS690, kind of like a TS450, pretty old radio. So it queries the radio, asks for the S meter reading, the radio responds, and the program writes the lat long S meter. Also writes elevation, which can kind of come in handy because sometimes the elevation is important. Like in the case of that first one where do I need to worry about a pole that's behind a hill? Probably not. So it does 60 samples in a minute. If I drive for 30 minutes at 1,800 data points, and in that 30 minutes, if I'm driving 20 miles an hour average, I can do about 10 road miles. So the advantage here is it's kind of a WAN tool, to put it in an IT term, wide area noise. It allows you to look at a lot of territory, and then you kind of filter out what you think is important and what is not important. And that's in contrast to the Yagi, the VHF Yagi, which is kind of a LAN or local area noise tool. You know, that's more like a quarter mile kind of a thing. And then the dish is more of a Ethernet segment kind of a problem where you can look at a very small area, you know, 50, 70 feet or so. The mapping for this is done with Google My Maps. It's not the same as Google Maps, and My Maps works really well for this kind of thing. It produced all the maps in this presentation. You can have up to 10 maps within a layer. You can have multiple layers, so you can retain all kinds of maps. Hardest part of doing all that was setting up an HF mobile installation. And initially I had to install Microsoft Visual Studio, which was kind of a pain to work with, but I think now I've gotten to the point where the package is standalone. It's just a program that executes off of the desktop. So what's involved with Mapper? Really just three things: a laptop computer, an HF transceiver, and I use a very old Kenwood TS690 simply because it works really well. It doesn't like power line noise, and when I get near power line noise, the S meter goes upscale. A couple of friends of mine have used K3s. They work good too, and I recently incorporated ICOM 705 into it. That works pretty good too. And then the third thing you need is a GPS. The GPSs are widely available now, and they're very inexpensive. I think there's another slide here. The GPSs are about 30 bucks. I think they went up a little bit now, about 40 bucks. So what did my noise situation look like when I started all this? So going back to January 2016, if you look at this map to my west, which was where I was having one of the problems, there's 6 major areas of concern. And yep, they were of concern. I've worked on all these over the years, and things have gotten much better. That's a little bit of what it looks like now, with the exception of the middle school, which I mentioned to you earlier. They fixed those problems, so it's green now. I don't have any problem to the west typically, unless something happens like a lightning storm or something like that. So really improved my noise floor. Does RFIM help me? Sure does. It's one of the things, or one of the tools I use pretty much every time I have to do an investigation, because things are many times more complicated than I first anticipate. Once the trouble's cleared, noise should go down. Otherwise, you didn't pick the right noise source. And it's also good because it's a great convincer for the power company. I can send them a map of what's going on, and they can look at that and go, yeah, this is a map. I mean, it's not personal opinion. There's a receiver looking at the noise floor, and sure enough, this area seems to indicate it. They used the Yagi to find the pole, and they used the dish to ID the part on the pole. So I try and narrow it down right down to the part, so there's no doubt about, yeah, we've done our homework and here's what's going on. Clearing distance guidelines. So how far out do you have to look for power line noise or other kinds of noise? If you have wire antennas, let's say at 30 feet in a tree, generally speaking, I usually think we need to look at it out to a quarter mile. That's pretty typical. If it's a really big noise source, you may have to go out a little farther than that, but a quarter mile is pretty common. If you have a 3-element beam at 50 feet, you're probably going to have to look out farther, more like a half mile if it's a bigger noise source. And if you have a multi-element Yagi at 100 feet, you may have to go out to a mile or even 2 miles. So I have a 10-meter Yagi, which I've used pretty effectively. It's a 90 feet. My noise level is usually about an S1 or S2, but I can hear things out to well over a mile many times when they pop up. And the longest confirmed issue I had was that first example. That was at 1.7 miles down a creek valley. And that was well over S9 at my location, even though it was 1.7 miles away. So when I drove by it with the mapper, it was S13. The RFI mapper uses a quarter wave ham stick on the back of my truck. So it's using a kind of an equivalent 0 dB gain antenna. The longest suspect issue that I found was a pole. It was 3 miles away. It was located on a 200-foot hill. So it was kind of elevated. Once the power company replaced the lightning arrestor, which was the defective part, the noise went away. So I'm pretty confident that was the issue in this case. It was the right azimuth. RFI mapper identified it as a hot spot, and the noise went away the same afternoon they worked on the pole.
There you go.
So what noise level is normal? Well, if you're on 80 meters, an S5 or S6 with a nice gentle hiss is about right. If you're on 20 meters, S3, S4. And if you're on 10 meters, S1 or S2 is what you want to see typically. I'll make mention of something, and it's the basis for so many of the things we do, but there's something called free space path loss, which predicts how much the RF gets attenuated over distance. And the important part of this is distance is part of the squared variable. And what that means, if you cut the distance in half, like when you're using RFI mapper, or if you're using the Yagi, the signal goes up by 6 dB. Or if you double the distance, it's going to go down by 6 dB. And you want to use that to your advantage. And one of the ways you want to use that to your advantage is if you're placing new antennas at your home QTH, if you can help it, don't place them directly over your house or in your attic. If you can help it, put them in the backyard and try and keep them away from all the noise producers. It'll help your noise floor tremendously. And I just went through this with a guy I'm assisting in Mississippi, where his end-fed half wave was in the front yard near the power lines, and he's in the process now of relocating that to the backyard where there are no power lines. He's got like 5 acres to work with. So keep them away from things that make noise. It's going to help you in the long run tremendously. So what makes noise inside my house? Here are the 3 things that I did a little survey with the Yagi. The first was the router group, where I have a cable modem router and a voice over IP system. That was pretty noisy until I quieted it down. And this is from the switching mode power supplies that are built into all of the modern electronic devices. They were the big culprits. So it was S7 on 80 meters. I got that down to about an S5 now, so about two less S units. We had a coffee pot in the kitchen, which was noisy. It made a great signal source to test my Yagi, but it's not what I wanted in the kitchen. So we kept it unplugged when we weren't using it. We only plugged it in the morning, and then we unplugged it when the coffee was done. And the third thing that was noisy in my house was a Dynex TV, a 32-incher. And we just simply flip it off. We have a power strip on it. We flip the power strip off. And those 3 things I found pretty easily by walking around and do a little survey inside the house. The switching mode power supplies, they can be really noisy, especially the ones that power battery chargers for lawn implements. Keep your eyes on those. Those can be very nasty things. My son-in-law did a remodel of his kitchen back a few years ago. And when he finished that up, he did change the lighting. He had some can lights in the kitchen and dining room. And then he called me up about a week later and asked me, why is it his TV stops working when he flips the can lights in the kitchen on? And he was doing over-the-air reception like a lot of people do for the local stations. So I brought my Yagi over there, did a little sweep, and the lights were just making all kinds of noise. I mean, they were like a plus 50 dB. And I said, "Where'd you get these lights?" He goes, ordered them off of a website. I'm not sure if it was via Amazon or somewhere else, but off of a website. I said, "Where were they made?" And he said, "China." I says, "Those lights don't come anywhere close to being legal." I said, "They must have skimped on the parts or whatever." But the LED lights were causing huge amounts of noise. So he's got to keep those off when he wants to watch TV. The second thing is if you do use a cable modem and a router, a separate cable modem and router, the router is usually powered by a wall wart that does not have any ground connection. So I added a short shielded cable from the cable modem, which has a good ground via the RG6 coming in, over to the router. And now the router has a ground. That helped quite a bit. And I also put a toroid on at each end of the power cable to confine the RF, but both those things helped. One word of warning, when I first went through this, I bought some cables off of one of the common websites, and the drain wire that's part of the shielded cable was not soldered to the RJ45 metal shell. It was simply laid across that shell and then compressed when they put the metal shield on. That caused the resistance that cable to range from 2 to 20 ohms. And I thought, well, that's not good. I took one apart and dissected it. And I said, I don't want these cables. I ended up throwing them in the trash. I ordered some Amphenol cables from Mouser Electronics. They had a spec sheet that showed the drain wire was actually soldered. The resistance on those cables was 1 ohm. So be careful what you order, and you kind of get what you pay for. Maybe these cables cost me twice as much. I think they were $7 at the time versus $3 or $4. But you want, when you order a shielded cable, you want good soldered connections at both ends. And so end result of my 80 meter noise level went from an S7 to an S5 by doing these things. So you learn a lot by investigating some of the stuff and doing a little bit of dissecting and playing around. Here's a picture of one of the things that powers my cable modem and a router. You can see I have a couple of toroids on there, and there's 4 different toroids are used pretty commonly, varying size all the way from 0.38 up to 0.72, depending on what you have to run through it. And these are small ones. I think I use the smallest ones for these cables. This cable's pretty tiny. It's maybe 3/16 of an inch. If you want to learn more about this stuff, Jim Brown, K9YC, Yankee Charlie, has a fantastic website. If you go to this audio systems group, and if you look on for his call on the internet, you'll find it pretty easily. There's more information on ferrites than you'll ever want to read. I mean, an engineer can go there and spend a week reading over stuff and analyze. What's that?
We know Jim. He tends to go on and on.
All right. Well, he's done a fantastic job on his website, and that's where this information came from. And I found it very useful. I have a supply of toroids. Matter of fact, there we go. There's my supply of ferrites. I have the small, medium, and large. And when I get low, I order some more, and we do group orders to get the high volume discounts where we order, I think 30 or 40 at a time of each one of these things. And I store them in some old peanut butter containers after they're cleaned up good, of course. But you want some of those around, so when you go out to investigate a problem, you have something to slap on the power leads, and trying to confine the RF to the device. And every transmitter needs an antenna, right? So what you're doing is you're keeping the energy inside the device, not letting it get out on the power cable, the DC power cable, and having that act as an antenna. So results, just to kind of finish things up here. The red line is what my noise level looked like when I started all this work some time ago. The blue line was a better day. It was still higher than I desired, but at least it wasn't killing me. It was an S3 on 10 meters. And when I finished, the red line is the noise level. And you can see I still had a little bit of a peak there to the east and down at about towards Australia, a little bit of a peak there, but well below my target of S2. So work does pay off. It just takes a little time to get there. So just to summarize, what do I do for noise problems? I try and clear the local area noise. I call it LAN, L-A-N, using the Yagi and the attenuator and the HT. And you want to make sure your own QTH is clear and very close to your QTH. If it's a pole problem, I'll work with the power company and use either their dish or my dish to locate the problem on the pole. And power line problems probably account for 80% of the noise issues I work. And then lastly, I think it's a wide area noise, the ham has a tower and a beam and need to cover a lot of area or get a kind of a picture of what's going on. I use the RFI mapper or the AM car radio. So those are the three tools I use kind of day in, day out for RF stuff, noise wise. Let me see if there's something else here. Now here's a really interesting one I'll just make mention because I spent some time chasing bunny rabbits. There was a noise problem along this stretch of road, and I thought it was a power line issue. So it showed up on RFI mapper sometimes, usually when things dried out, the ground got real dry in the fall time. And we'll go a month sometimes without any rain here in Georgia. And so I spent a lot of time going up and down this string of poles, trying to find the pole with the Yagi, and never really found anything. And I just happened to have the dish out one day, and I swept kind of like along the base of the pole, and I got some really strong hits. Turns out there's a cow fence here, and the cow fence is made of galvanized wire, and the wire, the verticals and the horizontal wires are tied together with this wrap. Well, this is a corroded joint. That horizontal line, which is running along this power pole for probably a half a mile, is getting voltage induced from the power line, and it's running along the horizontal lines until it can find a way to get to one of these poles, which normally the ground's wet and these poles are all grounded. But when things dry out, these poles no longer become grounded because they're only sticking in the ground about a foot or so. And it's got to travel down to the wet area to the right of this picture to find a good ground and then make the transition to the vertical wire and finally work its way to the ground. But turns out these joints, there were about half a dozen of them generating RFI.
So this isn't even an electrified fence, Jeff.
It is not electric. Well, it is in a sense. It's running parallel, kind of like a transformer.
Electrified, yeah. Wow.
Yeah, kind of like a transformer. So you run across weird stuff. Unfortunately, it only causes a problem when the ground gets really dry in the fall. We go a month without rain. But once it starts raining, the noise goes away. But I'm now aware of it. I don't go out chasing bunny rabbits trying to figure out what's going on. And I'm not going to repair this fence.
No.
It's not reasonable. Okay. Oops. I think that's about it of the important stuff. I've covered all the details. So any questions?
Hey, Jeff, what we'll do here is I just want to remind everybody on Zoom, please leave something in the chat. And then once we fill up the chat with questions, I'll throw the mic over to Ben and he'll surf through your questions here.
Oh, okay. Good.
So, okay. So we'll come first here at Coverly and we'll pick up some questions here.
Good evening, Jeff. Thank you for staying up so late for us here on the West Coast. Hope to work you field day, by the way, given that there'll be no noise. I have a story similar to yours. A couple of years ago, in fact, I wrote an article for our own paragraphs. I had S20/9, and actually even 30/9 noise from power lines. It took me a couple of years to really kind of focus this down, learning the techniques as you described, going in between the poles, using a Yagi on 2 meters really, but using a Yagi. And then I I had a friend of mine who came over and he pulled into my driveway. Now he normally listens to County Fire, which is 154. When he pulled into the driveway, his squelch was broken by the noise. That's how loud it was.
Mhm.
So we drove around, used the Yagi. We did our homework. I called PG&E. The guy that shows up, this is really funny. The guy shows up, he's got his PG&E uniform on, and he asked me, "Are you a ham?" And I said, "Yes." And he said, "My dad's a ham and he hates us." And anyway, he understood right off the bat what was going on. They sent a tech out. Like you said, we had isolated down to the poles. We think with maybe 2 or 3 poles. Net end result, PG&E did come out. They shut off power to 409 people, and replaced insulators on 3 poles, crossbars, joints, and the top insulator. Those were 7 kVA lines, 2 of them. And then and that brought the noise down to about S5. So like he said, do your homework. Don't just call them up. If you do your homework and you tell them where you believed you isolated it, what methods you use, you gain a lot of credibility. Anyway.
Yeah. And if you have to deal with them again in the future, you want credibility. You want them to believe what you're saying, and you want to get them to the poll, save them time, and get the problem fixed.
All right.
Okay, got another question here at Coverly.
We had a noise issue at Gail's house, and I thought it was the meter when I ran it down, and it turned out it was bus bar. I box, and when we replaced the bus bar, the noise went away. And then there's a device called a whole house line conditioner. Never buy a line conditioner that plugs in for a device, but a whole house one on, it costs about $100. And probably about that much more for an electrician to put it on.
All right. Oh, okay. Try again here. Okay, we'll go over to Keith here. We got Keith.
Hello, this is Keith, K1OKS. Something about the lightning arrestor. You had one that had rubber insulation on the outside, so you likely didn't have the ability to hear it from an audio dish. But you may be able to use something like a TRV 740, a Sony camera that has infrared night vision, if it's nighttime, to possibly see the infrared showing through the rubber. It might actually be somewhat transparent at certain light frequencies. You would have to go back at night, not during the day, but that might be another way to track down the source of your noise, at least in the form of a spark.
And the infrared pictures I've seen of units so far, there's 2 things that I had kind of like some doubts about. One is they show heat, which is good, but current passing through wires and joints generates heat. So the images I saw were kind of vague as to where the problem was. Yeah, there were some hot spots, but were they really issues? Not necessarily. If you're running, 500 amps or 400 amps at 7 kV through a main line, it's going to be a little warm. And the other thing was some of the parts on the pole, when you viewed the image, it was more of a cloud around each one of the parts, and the clouds kind of merged together. It wasn't very distinctive. So I didn't find the infrared views of the pole hardware too useful. I still find the ultrasonic seems to be the best thing, and I've had pretty good luck shooting from the directly below the lightning arrestor at the bolt on the bottom of the lightning arrestor. That's been the most effective. So just a FYI.
Okay.
All right, let me see if we, oh, yep, we have another question here.
I'm Jeff, AJ6WX. I've always been hearing about ball lightning, and I always thought that was goofy. There's no way that could exist. But there's this type of viewer made by FLIR, and what they do is called the solar blind spectrum. And it turns out the ozone layer blocks out a certain particular band of UV. So the whole Earth is kind of like a dark room, that particular spectrum. And so they made a viewer which views in the solar blind spectrum, and they also superimpose a daylight image over the same. So you get a picture of what you're seeing, and you get the funny solar blind view. And if you look it up on YouTube, you can see these funny views of when they're washing insulators with like deionized water. And so you'll see these funny ball lightning all around the insulators. And then they wash the insulators until the ball lightning goes away. And it's really an interesting look. I can't wait till solar blind viewing comes to the masses.
Yeah, some of the high voltage lines, the like 400 kV lines, they have special tools they use, like that viewer, to tell them if they have it cleaned off enough to to be able to go on to the next insulator. But those things, I've never found one of the high voltage lines causing noise. It's almost always the 7 and 14 kV distribution lines. A friend of mine supposedly had one that was causing a problem, and they said, well, in a year we're going to turn that line down and wash the insulators and check all the parts. But I haven't had much problem with the really high voltage lines that where the insulators are like 4 feet long. It's pretty uncommon. I guess from the standpoint of you can't afford to have one of those arc over, because you arc over at 400,000 or 500,000 volts, it's going to be a heck of an arc, and it's going to cause a pretty big outage. So they have to maintain those really well. They can't afford any leakage, can't afford trace paths between two dissimilar points, a high voltage point and a ground point.
Another question here.
Hey, this is Henry W6REK from Augusta, Georgia. And when I'm driving with my ham stick and on HF, I really noticed things like the quick trips and truck stops and stuff. And I wondered if how those compare to these power lines that you're finding, and also if solar cells on roofs are as bad as some have led me to believe.
Well, we have a great barbecue place here locally where if I drive anywhere close to that thing, I know exactly what you're talking about. I don't know what they use inside there, if it's lighting or exactly what it is, but I'm glad I don't live close to it, because it's a huge noise source. So I think that's an example of some of the things we may have to deal with as hams over the next 10, 20 years, is when those things pop up. If it's an LED light system and it's a neighbor, if we want to use our radios, we're going to have to locate it or assist in locating it. As far as solar cells, there's a couple different brands. One is quite noisy. I think it's Solar Edge. And there's another company I've heard, we don't have many here in the Southeast yet, that is very RF quiet. Kind of interesting. I did a couple presentations for clubs in Australia, and what they had told me was, gee, we have almost no problem with power line noise, but we have really big problems with solar panels. So they were interested in this presentation, not from the standpoint of how do I find bad power problems. I guess their lines are mostly 7 kV, but it's pretty dry there for the most part. I guess they have lightning storms, maybe not to the same level we have them here in the US, at least parts of the US. But by far their biggest problem was solar panels. I don't know what kind they were, but I think we're all headed towards that that scenario where we're going to see solar panels, and hopefully they clean up their act and get the manufacturers that are having the problems on the right path to subduing the RFI.
A question from Zoom.
Sure. Go ahead, Andy.
Yeah. What about the oncoming onslaught of electric cars? They're going to be all around you all the time.
That's could be a problem. Then they're talking about eliminating AM radios in the cars, but now Congress is talking about passing a law where they can't eliminate them. I hope that's the case, because if they can get an AM radio to work in one of those cars, that's going to be good for us from the standpoint of less RFI.
Yep.
Okay, Joe, I'll be right with you. Was there anybody on Zoom? We'll give them a chance. Ben, was there anybody else? Oh, there's one in the chat. Here, I'll have Ben read the chat. No one can answer that.
So a question from the chat. If your property has HV lines in the back and no room for an 80-meter dipole in the front, is it better practice to place your dipole parallel, 45 degrees or 90 degrees angle to the power lines? Does antenna orientation impact the noise floor?
Yes, it will. So whatever antenna you're using, if it's like a dipole, off the ends of the dipole would have the lesser reception. I would still say if your power lines are in the back, try and keep it as far away from those lines as possible. So maybe you want to use your house as the center support, or if you have a tree in the front yard where you can hide it effectively, use that as the center support and try and keep it away from power lines if you can. And also houses, you really don't want it, directly above, 2 feet above your roof. You'd like it to be as far away from the house as possible. I know it's a challenge on smaller lots, but it's worth the time and thinking about how you're going to orient it. I definitely wouldn't have it run parallel to and directly below the power lines.
I think the consensus here was 90 degrees. Is that what I heard?
Yep.
Yes.
Jeff, I had a quick question that has to do with the power companies. Since these poles seem to be so problematic, I would think that over the years, to better service the poles, they would have invented some sort of self-diagnosing circuitry on the pole, and it will alert the company when the pole's out of spec. But I guess maybe that's not cost productive, or I don't know.
Yeah, I have found for the most part, the power companies don't care, except from the standpoint it's disrupting their customer. So whether you're a homeowner or you're the cable company or a internet provider that's using DSL or something like that, then that's one of their customers. And those customers will complain when cable goes out because of a bad arrestor on a pole and it's infiltrating into the cable system. They have to take care of that. It's generating huge amounts of noise. But other than that, they don't care for the most part. I mean, they kind of view that as, well, it's been around forever. Nobody's complained about it. We're not going to be too proactive and go out and find every single arrestor that's making noise. And I think you have to kind of look at it from the standpoint of there's lots of small noise sources, and we probably don't care a whole lot about those. But some of the bigger ones, like that one where we had the bolt arcing to a metal plate, that would have been a safety issue eventually, but it was loud. And usually the really loud ones are the ones they need to pay attention to.
Well, I would like to think that in your neck of the woods, they've certainly appreciated your help. You've saved them a lot of time and effort.
Well, I try and make it as easy for them as I can. I mean, I try and tell them it's this part on this pole, and I give them a map and I give them a pole ID and the whole bit, because the easier I can make their job, I think it'll get them to the problem quicker. They're going to fix the problem I want them to fix. And hopefully the ham that I'm trying to assist is going to be happier.
All right. And I just want to remind all our Zoomites out there that our internet may dump us here. So if that happens, we'll reconnect, because it only gives us about 2 hours. But here we have another question here.
Yeah, I got another question for Jeff.
For Henry, that noise you hear when you drive by a truck stop is probably 50 truck drivers with 1,000-watt amplifiers on left beaters, because I can hear them at Quartz Fest at night on 20 meters when they were on 11 meters in the truck stop, splattering on 20. And 500 watts on 20 meters mobile will kill a hybrid when it's next to you, because I've done it by accident.
Thanks, Joe.
Don't like amplifiers.
I
All
got-
right.
I got another question.
Go ahead, Eddie.
Yeah, Hey Jeff, have you seen the cover article by W0 DSB in Colorado with his flag antenna for finding these problems?
I think it's WB8DSB, right, Don?
Oh, yeah, that's the guy. Oh, you've seen it.
Yep, yep.
I built one. It works beautifully.
Yep, I built one also. I also use a loop antenna, probably just because it's a little smaller and easier to handle. But yeah, I've talked to Don and or traded emails with him a number of times.
Oh, good.
Okay, we have another question here. Oh, looks like we got two. This is Shri KA6Q. So just a story about noise. Sometimes noise can come not appearing like a wolf, but dressed in sheep's clothing. I built this EME Yagi 17 elements or so, 5 meters long. And the idea was to stick it out of my window and see if I could receive signals, EME signals on the day when the EME contest was going on. Built the antenna, powered it up, connected up to WSJT on the laptop, immediately got a solid, nice, clean carrier at 432 megahertz, just what I expected. And then I realized, wait a minute, I hadn't quite pointed the antenna at the moon. So I spent the whole night trying to chase this. Nothing happened. There was no progress whatsoever. It was a solid signal that was constantly there, obviously not decoding anything. Didn't know what it was, but it was exactly on frequency. Then the moon shifted over to the other window. And when I moved the antenna over to the other window, I had to pull off some power plugs, some appliances, so that I could get get a different power outlet. And I thought, while I pull off the power outlets, let me continue to keep an eye on the receiver. And when I pulled off the HDMI splitter, that 432 megahertz was gone. So, you see the noise source inside your house might be a pure spectrum, single line, clean signal that could be bothering you.
That's a really good example too, why you want to do your investigation before the power company comes out. So when they come out, you don't chase the bunny rabbits down the holes and look like you're lost. So yeah, you want to investigate the noise source and have a pretty good idea, what's going on before anybody comes out to work on it.
I have another question here.
Hi, Jeff. David KM6RI. Thanks for the presentation, for your time tonight. And I see some of the information you presented on your QRZ page. Thanks for that. But wondering if tonight's presentation might be available to us.
Yeah, it's also, I think the Antique Wireless Association recorded this same thing in detail, the kind of longer version. Normally it lasts about an hour and a half. I shortened it up some tonight. But you can also view it on YouTube if you'd like. But if you want a particular slide or whatever, I can send that to you. Just drop me an email via the QRZ webpage.
All right, very cool. Jeff, one thing that hasn't come up is the when marijuana pot farms were starting to become legal, and those blasted lights were causing issues years back. But I guess the FCC tracked down on those, and I guess they're not as bad as they used to. Or has that been an issue in your neck of the woods?
I had one case years ago before LED lights were popular, when I went by one house and I thought, wait a minute, everything is underground power lines here. Where is that noise coming from? And it was pretty blatant. But fortunately, it was on the downside of a hill, so there was dirt between me and it, and I didn't have to worry about it too much. But I always wondered where that noise was coming from. But I think it's a relatively rare thing here.
Yeah, and of course, the trend in a lot of counties and states, especially here in California, it sounds like the goal is to gradually move all lines down into the ground. And I imagine as that progresses, our RF problems might get better, perhaps.
We hope.
Yeah.
But that'd be great, but I don't see that happening anytime soon because it's so much more expensive to bury the lines. You can do it in subdivisions, but it's really hard to do with the high voltage lines.
Unfortunately, we got these California fires that are getting
Yeah.
started by lines, and so they're anxious to do something different. So I don't know. Yeah.
All right, think we're gonna get our timeout timer here soon. So any last important question, whether on Zoom or here in the room? All right, Jeff, thank you so much for staying up for us. You're welcome to stay longer, but I know you probably want to get to bed. So everybody give him a hand. Thank you very much.
Thanks, Jeff. Great presentation.
Thank
Very
you.
good.
And by the way, Jeff, just for your own reference, we had about 20 something in the room and another 22 on Zoom. So it was about 44-ish people maybe. So thank you very much.
Good. Thanks for having me.